All right, I want to end this section on game theory with one more example. And in this example, I'm going to use the air alpha, air beta setup that we started with. I've rearranged the payoffs, and we will tell this story in a slightly different way. So first, let's do this. Let's set up the game in extensive form, and we'll find the Nash equilibrium, and then we will go from there. So in this game, air alpha gets the first move, and they either choose to provide a high level of output or a low level of output. And air beta gets the second move, and they choose either to produce a high or a low level of output. And the payoffs look like this. If both choose high output, payoffs are 1,000 for air alpha and 1,000 for air beta. If air alpha chooses high and air beta low, then the payoffs are 6,000 for air alpha, 2,000 for air beta. If air alpha chooses low and air beta high, then the payoffs are 2,000, 6,000, and if both choose low, the payoffs are 5,000, 5,000. So this game has the look of a prisoner's dilemma, where this appears to be low appears to be the best outcome for everybody taken into account, but we'll have to see whether we actually end up with that as the equilibrium outcome. So let's solve this first by backward induction. And so backward induction means we'll start with air beta, and air beta's strategy is going to depend on what air alpha does. So let's see. If air alpha chooses a high level of output, air beta will have payoff of either 1,000 or 2,000. They prefer the $2,000 payoff. And if air alpha chooses a low level of output, then air beta will have payoff of either 5,000 or 6,000. They'll prefer the 6,000. So for air beta, their strategy is to do the opposite of whatever air alpha does. If air alpha chooses high, they go low. If air alpha goes low, they want to go high. All right, now let's go back to air alpha and see what their strategy looks like. Air alpha says if air beta chooses low, then we have payoffs of either 5,000 or 2,000. We would prefer the 5,000. Oh, I'm sorry. I'm looking at the wrong payoffs. If air alpha says if air beta chooses low, then we're either going to be here or here. And air alpha either has payoff of 5,000 or 6,000. They prefer the 6,000. Sorry about that. If air beta chooses high, then we're either going to be here or here. And air alpha either has a payoff of 1,000 or 2,000. They're going to prefer the 2,000. Okay. So it looks like there are two equilibria here. Which one actually do we end up with? Well, air alpha gets the first move. And so air alpha has the first mover advantage. We saw this with the Stackelberg duopoly, where the leader in that model has an advantage because they get to go first. In this case, air alpha, since they get to go first, if they choose high, they know the outcome is going to be here. If they were to choose low, it would cost them. And so they don't do that. They go high. And this is the Nash equilibrium in the game. Okay. So from air alpha's point of view, it's not really a prisoner's dilemma. They're better off here than they would have been. And both firms come out with positive profitability, not as high as they would be combined down there. All right, so here's the Nash equilibrium. Now, if you're air beta, you're not very happy about this. And so air beta issues a statement. And their statement says, you know, we're happy to compete with Air Alpha. We respect them. They're great competitors, great peers. And what we really care about most is serving our customers, blah, 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 blah. And that's at the end of this statement, they say, we've decided that in order to be consistent with our corporate values, we're going to produce high level of output at all times. Regardless of what Air Alpha is doing. Oops. Okay. So they make this statement. Now, why would they do this? Well, if Air Alpha believes the statement, then it looks like Air Alpha has a choice between payoffs of either 2,000 or 1,000. It's clear that if that's the choice Air Alpha is facing, Air Alpha would prefer the 2,000 payoff. If Air Alpha chooses to go here, it's really going to benefit Air Beta a lot. They'll get the $6,000 payoff. So what they're trying to do, what Air Beta is trying to do, is to force the outcome of the game away from the Nash equilibrium and to push it to here. This is the outcome that most favors Air Beta. The question is, how should Air Alpha respond to this? Is this, and here's the key question, is this a credible threat? Well, we might ask, is Air Beta actually capable of carrying it out? Well, I guess so. They could choose high level of output. Of course, there's a risk for them. The risk is that Air Alpha just sticks with their high output and they both end up getting hurt. Nobody wants that. And so what does Air Alpha do? Air Alpha, if they're a rational game player, a rational player in a game assumes that the opponent will always do what is in their own best interest. What is in Air Beta's best interest? Well, Air Beta's optimal response to Air Alpha's optimal strategy is to choose a low level of output and move to this Nash equilibrium. The Nash equilibrium always tells us about each player's optimal strategy, what's in each player's best interest. So Air Alpha could take the threat seriously, or they could say, well, let them try. It's really not in their best interest. They're just going to be harming themselves. And we'll sit back and watch them do it until they can't do it anymore. And so the moral of the story is that a threat is credible only if it is in that player's best interest to carry it out. And in this case, it's not in Air Beta's best interest to carry this out. And so the threat is determined not to be credible. So a threat is credible only if it is in a player's best interest to carry the threat out. And since that is not the case here, we determine that this is not a credible threat. And that's the sort of conclusion that game theory brings us to. And now we have to back up and ask the question, do people really behave in credible ways in this sort of a confrontational situation? Game theory tells us to assume that they will, Experience may tell us that that's not always the case, but that's generally going to be our starting point. All right, I'm going to stop there.